quotient. Quotient rule, and let's look at a word problem before we move on. We are only 3 weeks away from the spring break. I have no idea how time passed by like that. Okay, so okay, I'm going to choose one. Let's say number 12. It's an ugly one. G of t equals 2t plus 3 the square root of t plus 5 and multiplied by the square root of t plus 4. And we're asked to find the g prime of t using the product rule. I will never use the product rule on this. No, absolutely not. I will distribute. But the reason why we study the product rule is because you will see what happens in the next section. Okay? So in the next section, we're going to have a power here, 4, for example, and here 5. It will take me a lifetime to take this to the 4th power and then take this to the 5th power and then multiply them and so on and so forth. So we need to understand the product rule and use it for something that follows next. So this is number 1 and this is number 2. Function 1, function 2. Let me refresh your memory. This is, do not try to invent anything here, please. So this is 1 prime times 2 plus 1 times 2 prime. Okay? So then g prime of t. Before I do anything, I will try to see if I can simplify. There is nothing I can do. There is no need to change this one. There is a need to change the cube root of t into t to 1/3. But there is no need to change the square root of t into anything because we have a formula that we memorized it already. Can anyone give it to me? Anyone? The derivative of the square root of t. Anyone?
E to the power of 1/2.
The derivative directly with no changes.
Would it be 1/2 t to the power of negative 1/2?
Okay, this is the answer. Moving forward, I'm going to ask this almost every class. This is the final answer, nothing else. 1 over 2 the square root of t. Okay, everyone? Jackson, is this okay?
Yep.
Savannah?
Yep.
Everyone? Haber?
Yep.
Rita?
Got it.
Noor?
Yeah, I got it.
Got it. Good. Okay, so when I differentiate this, since I already have written on the side and I will not have, maybe I have enough room. So I differentiate the first function. What do I get? Can anyone give us the derivative of this? Lake?
I'm sorry, I'm just not in it right now.
Okay, Gabby?
I can try. Is it t plus? No, I'm sorry, I don't know.
Shvam?
I can try. Would it be 2 plus you get rid of the 5 because it's a constant.
Excellent.
Is it 3 over 2t? T to the 1/2 to the power of 1 over 2. Or yeah, 2 square root t.
Very good. So this is the derivative of the first function multiplied by the second function. I have to copy it. Plus, I'm circling it so you know it continues here. That's a different thing. Good. I copy the first function. And now can anyone give us a derivative of the second one? Alex?
Is it 1/2 square root of t?
Thank you. Very good. So now we continue to distribute. I distribute the square root of t to 2. What do I get? The square root of t to 2, right? 2 the square root of t. The square root of t to 3 over 2 the square root of t. What happens when I multiply these two? Can anyone tell us?
Would it just be 3 over 2t?
Thank you very much. The square root of t with the square root of t will simplify. Plus 4 times 2, which is 8. And now 4 times 3 over 2, the square root of t will be just 6 over the square root of t. Because I simplify a 2, 2 times 3 is 6. So this is the first product. Plus 1 over 2, the square root of t multiplied by 2t. The 2's go away. So this is t over the square root of t. Then when I multiply these two, the square root of 2, or the square root of t will go away. So this is plus 3/2. And finally, plus 5 over 2 the square root of t. So I can do much. I can write the 2 the square root of t. These have the same denominator. So it will be plus t plus 6 over the square root of t. Then this is the plus 5 over 2 the square root of t. And this is 3/2 plus 3/2, which is 6/2, which is 3 plus 8, which is 11. It's good enough. I could find the least common denominator, etc., but that's fine. Let's talk about the quotient rule. Do we understand the product rule? Please say something, anything. Any questions?
I have a question.
Yeah.
Say it again.
I said I have a question.
Yes, please go ahead.
Okay. So when you were doing the derivative of t, why didn't you add the plus for, like, if you know what I mean?
You mean this plus?
No, that plus for, like, right, you did the root of t plus 4, like, why didn't you add the plus 4 after doing the derivative?
So I followed the rule. So I differentiated the first function and I got this.
Okay.
Then I have to multiply by the second function, so I multiplied by the second function.
Okay.
Then plus. I copied the first function. And then I multiplied by the second function. Oh!
Yeah, that one. But
Right, but
yeah.
okay. So what is the rate of change of a constant? How much does a constant grow or decrease?
0.
Right.
It doesn't.
A constant does not decrease or increase. It doesn't have a rate of change. It's 0.
Oh, okay.
Good. Other questions? Anything else? I thought, Haber, you had a question too?
I had a question.
Yes, Rita.
Yeah, I was just wondering, like, I guess, like, my biggest problem with the written works is that, like, missing the how to write it properly. So in this case, you didn't copy g of t or g prime of t for every single time you wrote the equals sign. Is that okay?
Yes, because this is not an equation. If I have x plus 2 equals 0, and I move 2 to the other side, I write x equals -2. I cannot write here. That's not allowed in an equation. But if it's an expression, yes. G prime of t equals this. This equals this. I didn't have enough room here, and I should have put another equal symbol, so you know it doesn't end, it continues. And that equals this, and that's it. But in the equation, I cannot have more than one equal symbol.
Okay, so when you say like to ensure you have the limit operator, what does that mean?
When we use a limit operator, I cannot put a limit operator if we don't use it. So the limit operator here is the limit of this, which continues to be the limit of this, which continues to be the limit of this. Now I apply the limit operator, because imagine I take the square root. I don't copy the square root again. Once I apply the square root, it's gone. Once I apply the limit operator, it's gone.
Okay, that's more clear, thank you.
Is that better? Also here, f prime is the limit, blah, 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 equals limit, blah, 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 equals limit, blah, blah, blah. I'm done. I'm applying the limit now. The limit disappears. This is final. Better?
Yeah.
What's this? Okay, that's a different homework. Okay, good. Any questions? Moving on. Great. I love it when you participate, when you ask questions. That's how it should be. Okay, the quotient rule. It means that this time we have a function over another function. Again, do not try to invent anything here. This is carved in stone, f prime times g minus f times g prime over g squared. So this is at the top is the same with the product rule, except that the product rule had positive and it didn't have a denominator. But the quotient rule, it has the difference at the top, the same with the product rule, but it has g not differentiated but squared. Okay, so let's look at an example. Okay, so let's look at a ugly one, 24. Like y equals 3x to the fourth plus 2x over x to the third minus 1. Okay, this is a mess, right? So this is the function at the top, the first one. So 1 divided by 2 prime. 1 prime times 2, of course I have run out of room, minus 1 times 2 prime divided by 2 squared. I'm going to write it again. 1 divided by 2 prime is 1 prime times 2 minus 1 times 2 prime over the second, the denominator squared. This is the method I'm going to use. This being the 1 and this being the 2. So then 1 y prime. I will start by writing the denominator squared, x to the third minus 1 squared, so I can forget about it for now. Can anyone differentiate the numerator for us? Yes?
12x to the third plus 2.
Great. So this is this piece. Now we have to multiply by the second function. The second function is the denominator. Now I reach this stage. I copy the negative symbol. Now I copy the top function, which is 3x to the fourth plus 2x. And now I reach the stage in which I have to differentiate the second function, which is the denominator. Can anyone give us this? Let's say Noor. Noor, can you give us the denominator prime?
Would it be x? Oh, the denominator prime. Oh, I'm not sure.
Anyone can help? Shvam, can you help?
3x squared.
Very good. Is this clear, everyone? Yes? This is what we covered last time, the power rule. Okay, so yes, I will try to make sense of the mess at the top. I will distribute and see what happens. So I continue. I'll distribute x cubed to these two. It doesn't matter how you do it. Maybe you're used to distribute 12x cubed to the other two and then come to, it doesn't matter. You use the method you like. I'm going to distribute from here. Sometimes I distribute from here. I don't know why I'm choosing this way this time. So 12x to the sixth plus 2x cubed minus 12x cubed and minus 2. Does everyone agree with the numerator so far? Do not expand the factors in the denominator. Do not expand. Leave it factored, please. Okay, now we are going to distribute 3x squared to these two terms. And keeping in mind there is a minus in front. Who would like to do this? Hey, Barry, I think you had a question before and I cut you off. My apologies.
Oh, I was just saying that the derivative of constant would be, the rate of change of the constant is 0.
Very good, thank you. So anyone who would like to distribute here, please?
So negative 2x to the 4th.
9x to the sixth. 3 times 3, 9, 9, x to the sixth, and then minus 6,
6x cubed.
the third. Very good. So we can simplify a little bit. So I will circle this because I don't have room on this page anymore. So you know where to find it. So this is my page 5. Here's my circle. So I have 12x to the 6th with minus 9x to the 6th. So that is 3x to the 6th. Then I have 2x cubed with negative 10x cubed, so that's negative 12, so it's negative 10 and minus 6. Minus 16x to the third and minus 2, and this is all I can do here. And this is done. Done. Okay, any questions? Any questions?
That's it?
That's it. Done. There is nothing else we can do here. We cannot simplify any further.
Is there a reason we don't simplify the bottom?
This is simplified. If you expand it, you're not going to be able to do anything with it. We always want everything to be factored. If I could factor the numerator, I will definitely do it.
Okay.
You want everything to be factored. All factored. We have more applications for the factored forms than for a bunch of terms that I don't know what to do with. Here I have no idea what to do with that. This is very easy. It's already factored. Okay. I wanted to, before we choose a word problem, I wanted to refresh your memory on